Okay. All right. So, okay, good evening again. Today, we will be concentrating our workshop on developing skills on how to build a project related to STEAM by developing skills in 3D and in Arduino. Good evening to everyone, and you are the most welcome. So first of all, I'd like to focus on the idea of that ICT teachers have or should be ready to start developing projects in STEAM by working on skills like the 3D printer, maybe Arduino, electronics, coding, and other skills related to this subject. What I'm going to show you is a really step-by-step to reach what we call a rotating solar panel using Arduino skills. So I'll start by sharing my screen. I want you please just to confirm me if you can see my screen on the chat. All right. So you can see my screen. Great. So I will start directly with the presentation. Sorry. So today we will be exploring together how to create a STEAM project in order to build a rotating solar panel. By the end of this webinar, you will be able to use Arduino and Tinkercad 3D skills in order to create this project. You can see here on the right the circuit designed in Tinkercad. We will be exploring it in detail in a few moments. So what we will be using. So in terms of hardware or software, what we are going to use is like the Tinkercad circuit, the platform, the online platform, Tinkercad circuit, in order to design our project, and then the Tinkercad 3D to design the skeleton of the servo motor and the rotating panel, and of course the Arduino software. So, and basically, if you have a 3D printer at school, you will need the software for slicing the design in order to print it on the 3D printer. I knew that some schools already have the 3D printer. That's why I'm developing this part. So what we will be using in terms of hardware, we are going to use the Arduino board, of course, the breadboard in order to create this complex project. We are going to use a servo motor, all right? And I'll be talking in detail about this servo motor, why it is used and where it is used. We are going to use two LDRs, and this is a photoresistor. It's an input device that can read the intensity of light in order to make the motor turns to the left or to the right. And of course, we need a multimeter, since we are going to measure the value of the resistor in case already they are used. So we have to implement the appropriate resistor. So we are going to use also two 10 kilo ohm resistors, okay? And of course, wires in order to create the circuit. And then we reach the moment in order to explain before building the circuit on Tinkercad. So we need to explain a little bit how the circuit is made. So you can see that there is a servo motor. It is here, and on both sides you have a resistor LDR with a sensor LDR with the resistor of 10 kilo ohm. So from this side you have one, and from the other side you have another one. So this circuit that you can see, it's really standard and simple in a way. So you can see that the LDR, I'm going to take one in real to show it to you. So this LDR, so it has two legs. So no difference between the two legs, same. And I'll be building my project by this way. So from the ground pin, I will connect to the first row of my breadboard. And then from the same row, I will connect one cable to one terminal from one side for the first LDR, and another LDR for the second LDR on the first terminal also. And of course, I'll be talking with the servo motor just in a while. So just I have to finish the LDR. So since the LDR, it has two terminals, from one side for one terminal, I will connect it to the ground, and from the other side, for the other terminal, you can see that there is two sides for the terminal. So from one side, you place the resistor of 10 kilo ohm, and you link with a wire to the 5 volt. And from the other side, you connect to the cable or the analog pin. So I'll be showing you this project. Hopefully it will be clear. So as you can see here, okay, so you have the LDR here, you have the resistor, and the cables are made in a way exactly the same as on the screen. Of course, this circuit that I've made, actually, it is only for one LDR, in order just to make it as clear as it is. And then I will be moving again to the screen in order to continue the explanation. So exactly same circuit I've made here, it should be made for the second LDR. And then for the servo motor, usually you have always 3 cables for the servo motor. You can see you have the brown, the red, and the yellow. So usually, I don't know if there is. I did not get the question from Khairiye. I don't know. So as I said here, the 3 cables for the servo motor are always with 3 colors. The first one, the brown, is for the ground. The middle, the red, it should be connected to the 5 volt. And the third one, the yellow or the orange, it should be connected to the digital pin the digital pin 6. We can connect it to any of the digital pins where there is the sign of PWM that can take analog data. So it could be connected to the digital pin 3, 5, 6, 9, 10, or 11. So I choose the 6. So here, if you go and see how pins are connected, so you can see that the first one, the red, is connected to, sorry, the brown is connected to the ground. The middle, sorry, the brown is connected to the ground, it's going up. The middle, the red for the 5-volt, and the yellow, it's connected to pin number 6. I'll be showing you live on Tinkercad how I'll be building my project and how I'll be creating the code. So, so here I go for the second slide. So to show you that in clear that I need one LDR with resistor, another LDR with resistor, and a servo motor. The characteristics of those components, so how they function, or how it functions. So for the LDR, when the light is low, it's like night, the value of the LDR is high. And when the light is high, the value of the LDR is low. So it's working in reverse mode. Okay? So this is what you have to know about the LDR. The LDR, it's like a sensor, exactly. So for the motor, servo motor, so it can turn 180 degrees. So it can turn to the left 90 degrees or to the right 90 degrees. And when it's on the middle, it's like for 0 degrees. And this kind of servo motors in real life, they are used like for the barrier gate, for the sliding door of a lift, or a shutter store for a window. So any movement that needs precision, we should use a servo motor, since we can control the rotation by degrees. So this is very important to know about the servo motor. And then after, we will introduce what we call the serial monitor, and I'll be showing you how it works. So what does it mean, a serial monitor? It's a monitor, it's a screen, it's a place where I have to see the value of the information that I'm reading from a sensor. So the figure that you are seeing on the screen, it's like an external screen. It's like an external screen where I can show data to be read from any sensor. But maybe you notice that the number of wires is extremely complicated and high, such a way I cannot handle this project during like 50 minutes or 40 minutes in the classroom. It demands too much skills. It demands too much skills in working on this LCD screen. That's why, as a curriculum, I always go for what we call the LDR screen, and I'll be explaining in a few moments. Now, when I reach the coding, so I believe that most of you that have tried let's say, what we call the Tinkercad platform. And this Tinkercad platform offers a coding with blocks to simplify the task. So look here how this code is simple, and I believe all students will understand it since they are used to work with Scratch. So you can see that there is a forever loop. So there is a forever loop where I print on the serial monitor the tool data that I'm reading from the analog pin connected to A0 and to A1. And there is a simple condition saying that if the analog of A0 is less than A1, so the servo motor will turn to 0 degrees, and else the servo motor connected to pin 6 will rotate to 180 degrees. And if by default the two sensors LDR are reading the same values, so the solar panel will be just in the middle. Okay? And Tinkercad will simplify the task, since from the software or the platform Tinkercad, you can directly convert the program created in blocks to a C++. So all that students will need to do is to copy this code and to put it on the Arduino software to make the upload and to try it as a hardware. So I'll be moving to the Tinkercad. I just want to confirm me by on the screen that you can see my Tinkercad. Just 1 second. Okay. Please confirm me if you can see my Tinkercad, please. Okay, great. So I'll be starting from scratch. So I go to the main page on Autodesk, sorry, Tinkercad. I will create a circuit. And this part is very important in order to let you know how I'm building my project. So okay, I remind you that by the end of the session, I will make a draw and there will be a winner for a complete Arduino set. So I'd like to say to keep you posted. It's a resistor, yes. Okay. So first of all, I will be moving an Arduino board. Then I will move the breadboard. I'll start by connecting a cable from the ground pin to the first row and a 5-volt to the other side of the breadboard. So like this, I can create my project. Then I'll be moving to choose the I will make for one LDR to have the time to finish the project. So I will take the photoresistor, which is the LDR. I will place it on my breadboard. And as I said before, that from the same row of the ground, I'll be taking a cable and I'll be connected to the column of the LDR. This is from one side. From the other side, I'll be taking a resistor. I will turn it. I will make sure that it is 10 kilo ohm. I will place it on the second terminal from one side, and I will connect my other side of the resistor to the 5 volt, excuse me. And still I need from the other side of the second terminal, I will connect it to the A0 pin. So my project will start like this, and I advise you to work with your students in such a way. I will stop my building for just one LDR. I will go to code and look how it will be simple to build my code. So I will move the from the output, I will move the print serial monitor, and then from the input, I will take the read analog pin. I will place it instead inside the hello code. And since I connect my LDR to the A0, so I will keep it with A0. And from the control, I will make like to wait 1 second. This is to start with my simple project. I will click on the start simulation. And if you look down below the blocks, you have a serial monitor. I will open my serial monitor. I will open my serial monitor. Okay. And you can see that there is a data shown on the computer, which on the screen, which is 969. So I will, to check if my program is working in a correct way as a simulation, I will select my LDR. You can see that there is a slider. I will move my slider, and then you can see that the value is changed. All right. So here, like I have minimum 49. So you see that when the light is high, the value is low. And when the light is low, the value is high. So it seems like my simulation is working correctly 100%. So I'll be moving to the other step, which is I will stop my simulation. I will keep my code open, and then I will go to the drop-down menu blocks, and I will choose blocks and text. And you see that the blocks are converted automatically to C++. So here I will select the code. I will copy it. I will go to my Arduino blocks or Arduino software, and then I will paste the block or the code I copied from Tinkercad. So you can see it's very easy to understand. So here you have the setup called the void, sorry, the loop setup, and the procedure loop. So it's showing on the screen with a delay of 1000. So I will check if my Arduino board is selected from tools, port, it's already selected. I will upload my program. I will upload my program. So you will see I will open my serial monitor. It's on the top right of the screen. And look here, it starts showing information or data. The moment I place my finger on the LDR to hide it, like if it is night, so it's showing 311, 308, 311, 304. And the moment I remove my finger, so the values are like 81, 82, and so on. So what I'll be doing, I will stop here my simulation. As you can see, it's very simple to move from simulation to hardware, and then I will go directly to again to Tinkercad. I will stop, I will hide my code, and I'll be adding a servo motor. So look how I'm moving step by step in order to make a complex project by the end. So I will move my servo motor, okay? And you can see once I place my mouse on the pins, it shows the name of the pin. So here it's ground. I will link it to the ground. This one is the power. I will link it to the power. And this is the signal. I will link it to pin number 6. I will make it like, all right. So it's done. Now it's time to create the condition in order to make the servo motor turn for one side or for the other side. And believe me, if you reach this point, the project is done. So I'll go to code. And since the servo motor, it's an output, so I click on the category output, and you see that there is a, let me move back to the blocks. You see that rotate servo motor to 0 degrees or 80 degrees and so on. So I'll be placing a condition, and I'll be creating from the math blocks, I will be moving this condition, which is if the read analog pin, I will place it here, is less than 100. So turn my servo motor connected to pin 6 to 90 degrees. This is it. It's done. And I'll be moving my system. So this blocks, or those blocks, if I click on start simulation, I click here on the LDR. Okay, you can see the data shown on the serial monitor. If I move to make it less than, sorry, I have to make the else here. So I will stop my simulation output, servo motor rotated to 0. So it's better maybe to make an if else statement. So I'll be moving the if else instead. I will place all the condition here. Okay. So this task is very simple for students. So start simulation. Okay. Once I slide sorry, excuse me. So it should be on pin 6. Start simulation. And then after, you can see once I slide, it moves to the left. Then it will take the position 0. Okay. I can make it here, for example, 180. Start simulation. This is 180. This is 90. This is 180. This is 90. So I did not attach my servo motor to the system, but if I click on the code and I choose stop simulation and I choose the block and text, look how it is simplified by moving from blocks to C++. So here also you can copy all the code and place it on your C++ program in order to upload it to the Arduino board in order to create the project. I will show you now a video for a real project. Give me just 1 second. It's like serial. All right, this is it. So please confirm me if you can see the video on your screen. Okay. Mrs. Okay, great. I will play the. It's okay. Mrs. Dalia asked me if this project could be done for grade 7. Look, for the first year, I believe it's a little bit hard for them, especially for the hardware. I believe this project could be given for higher grades like 9, 10, 11, or 12, but at least for 7, 8, you can start initiating the students for what we call the the simulator on Tinkercad. So I'll be activating the project, and you can see here. You can see here that there is two LDRs, one here, another here. And this is the servo motor. And what we are doing, we are moving the flashlight of the cellular to the left or to the right, and then the motor is turning to the left or to the right. Okay? I'm sharing my screen, no? Can you see the video or not? Sorry, can you see the? Ah, okay. Did you saw the motor? Okay, great, great. Okay, so I believe that just give me 1 second. All right. So now I'm showing the PowerPoint. All right. So now I'll be moving to the third part of the second part of my presentation, which is the share screen. Okay, share. Okay. So can you see my PowerPoint now? Can you see my PowerPoint? All right. So I'll be moving to the second part of this presentation. I will take not more than 10 minutes, which is how to create in Tinkercad 3D the design of the skeleton of the servo motor or the solar panel. And here I believe that even if you don't have a 3D printer at school, it's a very important task that you should develop with your students, because it gives too much creativity and challenge for the students to create those items in 3D. And maybe they can print it on a 3D printer outside. I believe you can find shops for this. So I've made this container of what we call the servo motor, where I can place my servo motor as a holder in order to place on it. It's made on a 3D printer. Okay, so in order to place on it, let's say the just 1 second to see if I can have my screw. It's not. Just give me, please, just 1 second. Okay, so I'm trying to fix the solar panel on my servo motor. Excuse me, just 1 second. It's not made 100%. It's okay, fine. So look here. What I've did, I've placed uh, my skeleton for the solar panel, which is fixed on. It needs to be fixed more. I don't find my screwdriver. All right, this is it. All right, this is it. Okay. So you can see here that I fixed my my skeleton for the solar panel here, and then I've created a skeleton or a container for the servo motor. So the big question is how to create those objects. And the main question again is how to know exactly the size of the servo motor or the ultrasonic sensor or the solar panel. So all those devices. I'll tell you it's very simple. And as you can see on your screen, it's already there. You can go on Google and you type dimension of a micro servo motor for Arduino, and it will shows you many pictures with precise dimensions. So here you can see that my servo motor, it has like 1.2 centimeters from this side, and from the other side it's 22 or 2.25 centimeters or 22.5 millimeters. So once I have those dimensions, okay, I will write them. So 1.2 by 22.5. So it's easy for, sorry, 12. So it's easy for me to create it with the Tinkercad. So I go to Tinkercad, I will open create a new design. After that, I will start creating my container for the servo motor. I will take a box, okay, and I will click on the box to select it. Then I will go to the device or the white squares that are all around the box. And here I will type 12 by 22.5. And I will make it a little bit down. So this should be the size of the base of my servo motor. But of course, I need another box bigger than that in order to create this one as a whole. So I will copy paste this one. I will make it like 15 by 25, let's say. Okay. And then the other one, this one, I will raise it for like 2 in order to keep a solid base on the box, and I will transform it to a hole, as you can see on the right. Then I will move it, and it will be very easy to align it. I will select both boxes. I will click on the align box, and then I will click on this one and this one. And here you can see that the box is aligned 100%. Now, I want my to open it from one side. So I will move a little bit my red box down. to the back. I will select both, and then I will click on the button group, and you will see that I've created a container for the servo motor. As simple. If you want to create the base like I've done here, you can draw any kind of shape, and you will place it down in order to fix it on the table or anywhere else. So this is how I create my object. I click on export, and then I will choose the STL extension. I will open my software for the 3D printer, and then we'll open it and we'll print it as 3D. It's very simple. Of course, you can find on the internet many libraries or many samples where you can choose a ready-made objects for Arduino. But here, it's an advantage for us to offer students what we call the 3D design offer. And for the schools who are using our curriculum, right click or 01, they know very well that there is a chapter on different levels for the 3D design. So I believe that like we are almost done. I will move step by step. First of all, before asking if you have any question, I will send you the attendance sheet on the chat in order to fill it. Everyone, all right. So I'm sending right now the Google form in order to fill it. Okay, so please start filling the Google form before making the draw on an Arduino kit. Did you get the Google form, please?